My name is Viva from SVCE. My USN is 1V22 IS059, and today we are going to talk about mastering swing. The agenda for today are as follows: the origin of swing. Swing is built on AWT, two key swing features, the MVC connections, components and containers, the swing package, a simple swing application, and then conclusion. So, the origin of swing. Java Abstract Window Toolkit was first introduced in 1995 with Java 1.0. This was the first GUI toolkit for Java. It aimed to provide a platform independent GUI development. But this AWT had a certain limitations. Namely, it was a heavy component, so it relied on native peer widgets. Each of the AWT component had a corresponding native component. This led to inconsistency across platforms. It also had a limited set of UI components, like very basic elements like buttons, text fields, and labels. This lacked any advanced components like trees, tables, etc. It was inconsistent look across the platform. Its appearance was tied to the host operating system, thus the performance issue with complex interfaces. Introduction of Swing. So the development of Swing started by Swing team in 1996 by Sun Microsystems. The first public release was in 1997 as an add-on to JDK 1.1, but it was officially included in JDK 1.2 in December 1998. This was designed to address all the AWT limitations and provide a more robust GUI toolkit. The key goals of Swing was to provide a rich set of GUI components, ensure consistent look and feel across all platforms, improve performance and flexibility, and maintain compatibility with the AWT. Swing is built on AWT. So, what is the relationship between Swing and AWT? Swing is not a replacement for AWT but an extension, so it is built on top of the AWT infrastructure. It uses event handling mechanism, layout management, top level containers to improve AWT. The key improvements over AWT were as follows. First was lightweight components. So there was no native peers. It had pure Java implementation. It was faster and more memory efficient. More extensive component set. So there were more advanced components like JTree, JTable, and JTabbed pane. Support for complex UI elements like menus and toolbars was also provided. It was more consistent looking throughout the platform. Same appearance on all platforms by default was provided. Option to mimic a native look and feel was also given. Great customization options. So easily modifiable components and appearance and behaviors was shown. Support for custom painting and border styles were also provided. Naming convention. So swing components generally prefixed with J, example J button, J field, J component. This helped distinguish from AWT components, which either started with AWT or swing J button. Coexistence with AWT. These swing components can mix with AWT in the same application. Some considerations were mixing. Example, the Z order issues. Now we have two key features in Swing. First is the lightweight components. So this was implemented entirely in Java, no reliance on native GUI widgets, rendered directly using Java 2D graphics. The advantages of the same were that consistent appearance across the platforms was given, more efficient, especially for the complex UIs. Greater control over the component behavior and appearance was also given. It was easier to create these custom components. Expectations, exceptions was only one. Some top level containers were still heavyweight and needed peers. Impact on performance, generally faster due to reduced native calls, may be slower for some very simple applications. The second one was pluggable look and feel, or PLAF. It was the ability to change application appearance at runtime. Separate component functionality from its appearance. The built-in look and feel options of Metal, which is the default Java look, Nimbus, the modern cross-platform look, system-specific looks based on Windows, Mac OS, etc. The custom look and feel could be created. Changing looks and feel was available with the help of UI manager or set look and feel method. Can be done programmatically or via configuration. So the benefits of this feature was that it consists UI across applications. It was easy to brand applications and it improved accessibility options. The next is the MVC connection. The MVC or the model view controller architecture was design pattern for separating application logic. It was widely used in all GUI applications. Swing components also follow the MVC pattern internally. So the components of MVC in Swing are the first is model, represents the data and business logic. It's independent of the user interface, example table model, list model, etc. Next is the view, displays data to the user, renders the model's data, example the visual components of JTable, JList, JTree, etc. The third was the controller. This handles the user input, updates model and view accordingly, open often integrated with the view in Swing, example event listeners, UI delegates, etc. The benefits of having MVC in Swing were as follows. Separation of concerns. It was easy to maintain and modify individual components. This also promoted code reusability. Improved maintainability and flexibility. So this could change data representation without affecting the view. It can also modify UI without changing the underlying data structures. Multiple views of the same model. Useful for complex data visualization. It was also facilitating unit testing, so you can test the model logic independently of the UI. MVC implementation in Swing. Most Swing components have a separate model class. Example, JTable uses table model, JList uses list model, etc. Custom models can be created by implementing appropriate interfaces. Some components combine view and controller for simplicity, and UI delegates acts as controller in many cases. Here is a small examples for few Swing packages. Example first is Java Swing. This is the core Swing components and containers. It has few key classes like Java component, JFrame, JDialog, JPanel, JButton, JTextField, etc. Java Swing.event is an event and listeners interface. It's a event classes and listener interfaces. Few of the key interfaces include action listener, mouse listener, key listener, etc. Java.swing.border. It's a class for creating and managing component borders, which included line border, title border, abstract border, etc. Java Swing.table was a class for creating and managing tables. It included classes like JTable, table model, table cell reorderer, etc. Java Swing.tree was used for creating and managing tree structures. The classes in this were JTree, tree model, tree cell render, etc. Java Swing text was text related components and utilities. This included JText area, JEditor pane, etc. Other important packages included Java Swing Plaf, Java Swing File Chooser, Java Swing Color Chooser, etc. Here we see a simple Java application which is showing us how to add labels, buttons, text fields, etc. onto a simple GUI interface. So Java Swing has been cornerstone of desktop application development in Java for over 2 decades now. It is built upon the foundation of AWT. Swing offers significant improvements, including lightweight components, pluggable look and feel, and a rich set of GUI elements. Its powerful event handling system and custom painting capabilities provide developers with the tools to create sophisticated and responsive user interfaces. Swing cross platform compatibility, extensive customization options, and mature ecosystem have made it a go to choice for Java GUI development. While it still faces challenges such as single thread nature, competition from one more modern alternative like JavaFX, and web technologies, Swing remains relevant and widely used to this date. To leverage Swing efficiently, developers should adhere to best practices such as utilizing design platforms, proper threading techniques, and regular cross platform testing. As the landscape of UI developments evolves, Swing continues to offer a reliable, well documented framework for creating robust desktop applications, supported by the wealth of resources, including official tutorials, open source projects, and an active community. Whether building new applications or maintaining existing ones, understanding and mastering Swing remains a valuable skill in a Java developer's toolkit. Thank you guys. Have a great day ahead.